show that the initial speed is 4 meters. So let's do that. We know it's 18 meters there. We know the final one is 8 meters per second, and we know the time is 9 seconds. So therefore, what we can say is a whole variety of ones we can try and look at. I'm going to use S equals a half U plus V T, because that's the only one really with these three that you can use if you're trying to find U. S is 18 equals a half U plus 8 times 9. Double everything, 36 divided by 9, 4. So that is 4 equals U plus 8. So U equals negative 4 meters per second. So the speed, initial speed is 4 meters going the other direction, but that's initial velocity. So now we need to find the acceleration. We've got the initial velocity as well now. So the acceleration, V equals U plus AT. So 8 equals negative 4 plus that times 9. So add 4 to both sides. 12, 9, A equals 12 over 4 divided by 3, 4 over 3 meters per second squared. So that's now there. Right, so I'm going to use this now to show that it can never be at B. So that's minus 10 equals minus 4t plus a half, 4 over 3 t squared. So 2 over 3 there. So that's 2 over 3 times everything by 3, then divide everything by 2. So you get minus 30 equals minus 12t plus 2t squared. So you get minus 15 equals minus 6t plus t squared. Tidying that up, I end up with t squared minus 6t plus 15 equals 0. And if you can never get a value of t here, you look at the discriminator and see that that must be less than 0. So therefore b squared, which is there, so that's 36 minus 4 lots of 1 times 15 is 60. That is less than 0, so it can't work, it's undefined. Boom. Right, now it says the second particle q, you can read that. So the displacement of q at O is x equals a t cubed plus b t squared plus ct. This is displacement. So if I want to find the velocity, I'll differentiate that because that is distance over time. So if I differentiated this, that would be the xt and that could be my velocity. So that'll be 3at squared plus 2bt plus c. Why am I doing this? Well, because I need to find the coefficients a, b, and c. I need to find that, and I've been given some parameters here in which to do that. So for instance here, I know the velocity is minus 4 when t is 0. So for that reason I can work out c. Because I know that's minus 4 when t is 0, then c must be minus 4. So now I've got my value of c as negative 4 from there. And equally I can work out what my b value is, because I know the acceleration is 4 over 3 when t is 0. So the acceleration is a differential of the velocity with respect to time. Because remember, it's meters per second squared. This is meters per second, acceleration is meters per second squared, and that always helps me understand how to do things like this. So acceleration is going to be 6at plus 2b, but I know that when t is 0, the acceleration is 4 over 3. So therefore, that 0, 2b equals 4 over 3. So now I know what my b value is. My b value is going to be 4 over 6, 2 over 3. So now I know b equals 2 over 3, and that's all really good. It then asks, I need to find out a. So I need to work out what a is. I can do that from this point here because I know they're saying the displacement when time, I think it is, time is 6, the distance is 18. So here I can do 18 equals, and it's a times 6 cubed plus, now my b is 2 over 3, so it's 2 over 3 times 6 squared, which is 36, and it's my minus 4 times t as well. So if I were to sort all this out here, I'd get my a value as being 1 over 12. My a value as 1 over 12. And that's how I get my 3 coefficients, by just going through it gently, like that. Now that I've got a, b, and c, how do I work out the velocity of q at a? Well, there's my velocity formula that I want to do. I want to put these things in, and I simply put in when t equals 6 into here, and I'll find my velocity. So some fractions in here, but let's just go with it. So that's 3 lots of that, so that's a quarter t squared. So that's 36, because we're saying, remember, t is 6, plus 2 lots of that, so it's 4 over 3 times 6 minus our 4. So that's 9 plus 8 minus 4, so that's 13 meters per second. There you go.